Hi, everyone. Welcome to a Conveyor meetup. Today we have Justin Goldsmith and Ryan Goodson who will be presenting to us. Before I hand it over to them, just want to let you know that if you want to keep getting meetup invites around how to migrate Kubernetes and just updates on open source tools that can help you with the transition, make sure you sign up to the Google group. I'll be putting the link in the chat here in a couple minutes. And aside from that, I will send out the recording and the slides to this meetup to that exact email list. And also, just save your questions for the end of the presentation. You can go ahead and put them in the Q&A throughout the presentation, but just know that we won't get to them to the end. And that way the presenters have time to get through all their slides. So with that said, Ryan, Justin, it's all yours.
Thank you.
Thank you, Jonathan, for the introduction. Let me start sharing my screen and we can start talking. Okay. This is migrating traditional and existing cloud workloads to OpenShift. I'm Justin Goldsmith. I'm a senior architect on the Red Hat Financial Services consulting team, and I've worked with tons of our clients on moving their applications onto OpenShift. Ryan?
Well, I'm Ryan Goodson. I'm also a senior architect with the Financial Services Consulting arm of Red Hat. I've actually only been with a single client, but I've been with them for nearly 3 years now, and have been working with them on migrating their applications to OpenShift.
All right, so today will be probably a little different than most of your typical Conveyor meetups for those of you that have been to these before. We're going to talk about the Conveyor tools, but we've been working on migrations with these clients for longer than some of these tools have existed. So a lot of our best practices and patterns that we've used actually haven't leveraged the Conveyor tools as much. We're going to talk about what we've done, and then at the end we'll talk a little bit about the tool set as part of Conveyor, of what we can do differently in the future and how we will and are starting to leverage them. All right, so this is a Conveyor meetup, so I'm not going to go too in-depth into Kubernetes and OpenShift. Hopefully most of you have a good idea of what they are. If you don't, obviously definitely spend some time reading about it afterwards, and there's tons of good groups that can talk about that. But just quickly, Kubernetes is an orchestration framework for containers. OpenShift builds on top of that, providing some more app development-centric tools and a bunch of other things. For kind of managing and deploying your apps on top of Kubernetes, right? So obviously we have built-in logging with OpenShift, built-in registry, built-in ingress layer, service mesh, serverless, and then CI/CD, Jenkins, and a bunch of tools for basically facilitate application development on top of Kubernetes. So why are we here? We're here to talk about how we can actually modernize your application delivery and move applications onto Kubernetes. So we need a cloud to do that. So we need OpenShift, wherever you want to run that, on-prem, in hybrid, in public cloud, both places. We need to talk about the processes for how we deliver our applications onto it. We need to automate as much as we can. We need to up the skill set and make sure our delivery teams are capable of moving workloads onto OpenShift, and we need to organize them in a way that we can do that. We're going to talk about all these as part of this presentation. All right, so there's lots of different migration types. For the most part, we're going to talk about, I guess, a form of lift and shift here, about how we can move workloads mostly as they are onto OpenShift. We'll talk a little bit about how we can refactor and replatform them and kind of change them a little bit if they're not capable of running an OpenShift as they are. All right, so we're going to talk about two different clients use cases that both myself and Ryan have worked with. The first one is my client, so I'm going to go through it, and then the second client is the one that Ryan's been working with for 3 years on this. So you'll hear a bit about both of them. All right, so when we first went in there, what was the most important thing? What are we trying to do? Obviously, we work with the app teams, but that's almost secondary initially. The first thing that we tried to do was try to standardize as much as we can. How can we standardize provisioning and giving access to OpenShift? How can we standardize CI/CD and deployment, configuration management, logs? We need to basically provide a way to give these functionalities to the application teams with them being as basic of users as possible. Obviously, we want them to be skilled up in OpenShift and Kubernetes, but that isn't always the case. And again, we're talking about two of the largest financial services clients in North America. So the development teams are what they are, and we work to skill them up. But again, we want to make this as easy as possible for them. So we try to standardize as much as we could. Right. The first thing we tried to standardize is the CI/CD pipeline. This is not their actual CI/CD pipeline. This is kind of just a generic stock image, but we did do all of these steps, right? So we obviously need to build the application. So that's, Maven for Java, whatever we're using for Python or Node. Basically, we need to build the application artifact, build our images, implement security scanning tools, signing, deployment to multiple levels, right? Production, dev, QA, UAT, production, and try to make this as simple and as consistent as we can for all of our application teams, right? So let's get into actually what the reusable processes that we built are. So first, onboarding. This is really important. I've worked with clients that don't do this well. It might take, we're moving to a container world to try to make everything faster, but yet sometimes it still takes 2 weeks to do onboarding and get permissions and everything. So this client actually built a whole onboarding portal about how they can onboard onto OpenShift. And more than just OpenShift, really, this is their platform for their cloud deployments in general. But OpenShift is inclusive of that. So what does this do? We're able to give developers, testers, and operations teams the permissions they need. So it gives, for example, developers edit access in their dev namespace, testers that access in QA and UAT, and the operations team are the only people that get that permissions in their production clusters. We create namespaces, so we create dev, QA, UAT, production, whatever namespaces these application teams need. And then we also create a way to inject the default configuration and templates that they need to get started into their Git repo directly. I, again, don't necessarily agree with everything they did. For example, creating namespaces. I'm more of along the lines of create them when you need them. So, for example, if we need a feature branch, create a namespace for the feature branch when you're trying to deploy it. Same thing for all really clusters. But they were kind of wanted their historical pattern of having these 4, 5, 6 static environments. So they created those to begin with, and then the next step is they provided a way to have multiple environments, right? So we don't need to just talk about tools to migrate. We need to talk about how it's actually useful for them. So we want to be able to deploy feature branches, release branches, basically deploy multiple things at the same time. And that's super important because if developers are working on 10 feature branches at the same time, we want to be able to deploy all 10 of those. Right now in existing environments, that's kind of a challenge, not the easiest thing in the world to do because they might only have 1 or 2 dev environments. So that's a pain. So that's a huge value add, right? We definitely want to be able to support that. And they do that by essentially changing the name of the objects in the OpenShift namespace to basically be prefixed by the branch. Again, I would have preferred them do that by creating individual namespaces, but the important thing is that they're capable of doing it, and we can deploy as many feature branches as we want at the same time. Another thing is how do we manage configuration? Right, so developers might not be super familiar with config maps and how all that works. How do we deal with configuration in different environments? How do we change config dev versus QAT versus for all those feature branches that we have? So we built basically a templatized way of doing that for them. Things like Kustomize or Helm might support this a little bit more natively out of the box, but they didn't use those at the time. And part of that reason was because they weren't allowed to run things that required cluster admin permissions, like Tiller did for Helm in Helm 2. So when we built this, we used OpenShift templates to manage this. So basically, we created a configuration repo that held the configuration, and it had a folder per environment, so that we can basically plug and play things that changed in those environment folders. And then as part of our CI/CD pipeline, we actually merged it together for them to create the individual config maps they needed, and then deployed it when we deployed each application to each environment. Another important thing to talk about here is deployment of configuration. We don't only want to be able to deploy configuration when we're deploying our images. Configuration can change outside the lifecycle of your application. So it's important to be able to build a process to be able to manage that and be able to deploy config outside the scope of deploying a new version of your app, because they don't always overlap. All right. Secrets are a bit tricky. OpenShift obviously has secrets. Kubernetes, they're just Kubernetes secrets. A lot of our financial services clients don't like using Kubernetes secrets because they don't think they're secure enough, which is a valid point, right? Like Kubernetes secrets, sure, in later versions of Kube and OpenShift can be encrypted in etcd. But if you have edit access to the project, they're just base64 encoded when you get them. So really anybody with the right permissions in the project can see the secrets. They're stored in etcd, so they're not just specific to the application. So we wanted a way to basically use an external secret store and kind of build a standard process for that. And it kind of was managed in a similar way to our config. Basically, we created, they were using HashiCorp Vault. So we created essentially a YAML file that defined what secrets in Vault needed to make their way into what OpenShift, pods. And then we just kind of mapped them together and injected them. We built an init container. So basically a container that launched in the pod before the application started that could move those secrets over into the main application and share them via an empty dir between them. It could also set environment variables. But to do that is a little bit different. You can't set an environment variable from container A in container B. So we had to modify the entry point and create a standard entry point that these application teams could use if they wanted to use that feature to basically source their secrets from Vault as an environment variable. HashiCorp also has their own Vault agent that basically works in a very similar way to what we did. This client didn't want to use it for whatever reason, so we basically mimicked it as much as we could and added some extra functionality that the Vault agent didn't provide by default that this client wanted. Right. So again, secrets, standardizing how they do them are really important. We did use the kube auth mechanism of HashiCorp Vault. So to authenticate to Vault, to be able to grab secrets, is basically relying on the service account in the pod. So it sends that service account token to Vault to basically be able to get permissions to grab the secrets from Vault. Right. So that is, at the end of the day, a Kubernetes secret, that token. So, you still are reliant on it somewhat, but most of the mission critical secrets are kept external to OpenShift in this case, in this client. And I've seen that pattern at more than just this client that we're talking about now. Logging, really important to build a standardized way to do logging. OpenShift comes with, EFK, so Elastic to store the logs, Fluentd to send the logs to Elastic, and Kibana to view them. This client's built-in OpenShift logging stack, again, only this was their design decision and how they wanted to do it, but it only basically stored logs for a couple days. It wasn't meant to be the long-term logging storage solution. So they left that to application teams to kind of figure out another way if they wanted to have logs for more than 2 days. So we built kind of various patterns of different integrations that they can work with. So for example, Splunk we created a mechanism for them to basically have a Splunk sidecar container to forward their logs to Splunk. Same thing with FileBeats and Logstash, just, other log forwarding agents that can send to Elastic or other log stashes. At a different client, we actually used the Splunk FluentD to run on all the nodes to send to Splunk, but again, that was their choice because they used kind of Splunk as their enterprise logging solution, and they wanted to do that with an OpenShift too. So we haven't done this yet, but there's the new log forwarding API that's part of, I forget when it became GA, but it's definitely around in 4.6 right now, which is pretty powerful, right? Because we can basically provide namespace filters via a custom resource that specifies where we want our logs to go to within OpenShift with OpenShift FluentD, so we don't need to do any of these integrations. So for example, if we want to send logs to Kafka for, X namespace, we can do that. I don't remember if Splunk is part of that or not, but we can send it to an external log stash that, forwards us somewhere. So application teams no longer only have to be reliant on the OpenShift logging stack. If we want to, we can use the OpenShift logging stack to forward along. One kind of important piece here is, again, that OpenShift logging and this log forwarding API will only work for logs that are sent to standard out or console, right? So if your logs are still in a log file, we have work to do. Either A, we need to use one of these sidecar patterns so we can, tail this log file and send our logs where we want to via Splunk or Logstash or something like that, or we need to modify our apps and to send logs to standard out so that the default mechanisms of OpenShift can pick up those logs and send them where they need to go. Metrics are super important in how we standardize those. This client used Dynatrace, so basically the agent was injected automatically in every single container that got brought up, and we just had to set a couple of environment variables so that those metrics were sent to the right place. We can also use user-defined metrics in Prometheus, right? Obviously, Prometheus will track by default, like, CPU, memory, some network-related information, but it doesn't, not specific for Java, for example, right? It's not going to give you as much information as like a Dynatrace Java agent would give you, or any of those app monitoring tools, right? So we need a standard way to deal with metrics, whether that be some external tool or whether that be documentation and standards for how we can use user-defined metrics in Prometheus to grab more information. Failover patterns are super important here. We built GTM automation for them. So for those of you that don't know, GTM is a global transaction manager. I might be getting the acronym wrong, but basically it's a DNS device that will, based on where you are, give you an IP address for whatever DNS entry you're putting for your requesting, that will send you to somewhere, right? So in our case, we basically provided two patterns, an active pattern or an active standby pattern, where we automatically define the health checks so that if an application failed, it would only send traffic to the right place. So for example, if we have OpenShift cluster 1 running in data center 1, OpenShift cluster 2 running in data center 2, our deployment pattern deployed the application to both of those by default, spun them up, so they both, let's say, had 5 replicas of each application running in both places. And if we wanted to, and when we failed over, it was automatic because we kind of built that and standardized that for them. And again, all they had to do was decide whether they wanted to send traffic to both places by default or start in one, fail over to the other when it failed based on their health check. Now let's talk a little bit about other, application patterns. We talked a lot about, kind of things that we needed to do during the deployment and provisioning process. But what about, kind of other, common things that we need? Base images. We have lots of different types of applications that we can run in OpenShift. Red Hat provides base images for tons of them. JBoss, obviously. All of our source to images like, Python, Node, kind of a ton of them, right? So, but most of the banks want to provide their own little spin on top of them. So we basically made several base images that our application teams could use and use those as a starting point with all the bank layers kind of built in already. So we did that for JBoss, we did that for Python, we did that for Node.js, we did that for WebSphere Liberty. So a bunch of different application, base images. So this migration was actually a migration from Bluemix, or at least started as a migration from Bluemix to OpenShift. So that's why we did WebSphere Liberty. A lot of their workloads were either running in WebSphere Liberty or Spring Boot. So those were kind of the two main ones we focused on, of how we can kind of standardize the deployment of WebSphere Liberty and Spring Boot and OpenShift. Some of the other applications were also JBoss and Node, but most of their workloads running in Bluemix were Liberty or Spring Boot. Object store integration. So this is kind of a big one. How do we get information into and out of running pods? This was not an issue for the Bluemix migration because it's Cloud Foundry, so there wasn't any persistent volumes really for any of those workloads because it doesn't support it over there. But for when we're talking about kind of more VM-based or bare metal-based deployment, a lot of them have NFS mounts, and their admins will go into those NFS mounts to grab log files or to inject configuration kind of manually, and they expected to be able to do that in OpenShift. And while you can kind of do that in OpenShift, you can mount it, an NFS volume to your pods. Most of the financial services clients that I work with don't give you permission to mount that outside of OpenShift. So if you want to be able to get access to that mount, you would have to RSH or rsync into the pod directly. And a lot of our clients, including this one, blocked that in production. So there's no way to RSH rsync into your production pods. But they still have these legacy mechanisms of, I need to pull my log files down, or I need to inject this configuration at startup. So how can I do that? So what we did was built an object store sync. So basically, we had a sidecar container that had the Amazon S3 library in it, and it basically just did a sync between some object store bucket, as long as it was compliant with the S3 API, and an empty volume on your container, so that it can be shared between container A and container B running on one pod. So for example, if we needed to pull down logs, we can set this to basically sync our log director every 5 minutes with some S3 bucket. Or if we needed to inject configuration, we can go the other way, configure it to sync from the bucket into the pod. So that was just a pattern that we saw lots of application teams needed. So we built for them. Another big one was MTLS. So how do we do mutual TLS between various components? This is less of a big deal for things running inside of OpenShift, more of a big deal for things running out to in. The OpenShift routing layer does not really provide a good way to do this. So you have to basically do a pass-through route to do termination at your end state at your pod. So what we did was basically just built a little proxy to sit in front of it. Configured a standard way to add certs to it to basically have all MTLS traffic done this way, so the app teams didn't have to configure it themselves. Istio does a lot of this for you if you're talking about things within the service mesh. I think it can even do things for MTLS, inbound, even if it's not from the service mesh. But this was mostly on an OpenShift 3.11 cluster before Istio was around, so we needed to basically have a standard way to do this. Bluemix also had a default way to do caching inside of Bluemix. They provided a caching service, which OpenShift does not have out of the box. So we basically built, using JBoss Data Grid, built a way that application teams could scale up a cache on demand to modify their application slightly to talk to the JBoss Data Grid cache running at OpenShift instead of the Bluemix cache. And then single sign-on. Single sign-on, we did support it inside of a proxy in front of it, but most of the single sign-on work was done for the individual base images, right? So we figured out how to do single sign-on in WebSphere Liberty. So the 25 app teams we worked with that were using WebSphere Liberty can all do single sign-on the same way. again, and there will be tons of these patterns. These are just some of them that we implemented, but every organization will definitely have different ones, and kind of building them out in a standard way helps, because then multiple application teams can leverage them and use them. So how did we kind of model our team? So we started out with a core adoption team. This was made up of people like myself, Red Hat consultants, also some people from our client, and then we worked directly with the application teams to help them onboard, right? So we also worked with the teams at the bank that were building these platforms, so like the CI/CD platform, another team owned. We built a lot of the integrations ourselves, but this was kind of how we started. And this scaled pretty well. We were able to work with 10, 15 application teams at once. But we were moving 100 different applications, and that didn't work within our timeline. So then we kind of scaled that. We built kind of like a shared services team. So this was the team that would have managed all those kind of shared integrations. So how do we do SSO? How do we do MTLS? So we built a lot of those out of here. And then these core teams were built up of both Red Hat resources and client resources that were kind of experts in OpenShift and Kubernetes to work with all the various application teams and facilitate their onboarding. Usually this would start very heavy when the application teams were inexperienced. But if an application team owned 20 services, it might only have been pretty heavy for the first 2 or 3, and then they kind of got in the groove of it themselves, and we kind of just supported them as they needed to be supported for any issues they ran into. So that was kind of our use case and kind of how we dealt with it. So now I'm going to hand it over to Ryan, and Ryan's going to talk a little bit more about second client that he worked with. Thank you, guys.
Thank you, Justin. And thank you, Justin. And apologies, I actually live in a rather remote area, so I don't have video. So anyway, so to move on, in my particular client, it's actually very similar to a lot of the work that Justin has been doing with several of our other clients. But we had some notable challenges that were a little bit different. The biggest one that we had to face with the team is just pure scale. To give you an idea, at the beginning of this year, my client is up to 200 OpenShift clusters and knocking on the neighborhood of about 10,000 cores. So you can imagine just the sheer size of this environment. When I first joined the team and started to help with the application onboarding, it was just as the environment was certified for production. So, now it's, all of the POC has been done, and, all of the kicking around of the environment was complete, and now it was time to get serious, time to start to move these applications over. Unfortunately, though, the client actually chose to attempt all of these migrations on their own. Between the sheer size of it, and there were multiple sectors that were looking to do the migrations, there wasn't really a unified approach available to us. So we kind of worked in an individual sector. I worked with one sector, and one of my peers worked with another sector. However, because of our collaboration, we were able to share a lot of information between the two. And that really helped them kind of stay on track on using as unified of an approach as possible. And as we went on, and as we onboarded more and more teams, we actually started to look at focusing on the skills of the application team, because a lot of them had been mandated by their management that they need to migrate to their platform, and so how they didn't have really all of the background information or the skills necessary to begin the migration. And so we put together a kind of a container roadshow where we were able to go out and visit with these application teams in the pre-COVID days, and then sit down with them and give them a general overview of containers and Kubernetes and OpenShift, and then start to work with them to begin their migration. And as we went along, and as the platform started to expand within the client, we actually built out a lab environment so that during our sessions, we would spend the morning going over the training pieces and getting them up to speed. And then in the afternoon, we'd actually sit down with them and get their application onto this lab environment and get it stood up and get them going. And so that really helped make it much easier to start those migrations and getting them going. One of the other things that we ended up having to have a challenge was the variety of targets. So not only did we have them available inside the data centers, we were also leveraging the public cloud. So being able to help the developers migrate an existing application, or in some cases, actually developing a brand new application. And then, then we had all of the variables on, well, is it on-prem or is it, out in public cloud, and all of the security controls that are all related to each of those deployment types. Next slide, please. So with that, as we went along, we started off doing a lot of manual work. And then from there, we were able to start to build out templates to make it easier for the application teams to be able to start a little bit further ahead and be able to move forward with getting onboarded and getting our application in place. And then as we went along, we actually started to look at the tooling. What tooling could we use to make it easier? And so we started to leverage the migration toolkit for applications and actually plugged that into the CI/CD pipelines for a number of different teams. And that way, as those teams were doing their regular development work, they were actually getting reports back on how well their applications scored on migrating to the container environment. And so that started to help give the application teams a better idea of the difficulty and level of effort necessary to do the migration. And come to find out that, for the most part, it was going to be relatively straightforward for them to do the migration. And so because of that, we were able to increase awareness and increase the desire to actually make that migration. And so now we're really looking to move, expand out that tooling and getting more into the automation side of things to be able to, further accelerate the migration to the environment. Next slide, please. So how do we accelerate it? Really what it comes down to is that we need to lower the barrier of entry to bring the applications onto the platform, whether it's pure Kubernetes or OpenShift itself. And really what we want to do is start off by having a very easy way of converting deployment artifacts from other platforms that are currently in use. Being able to plug into an existing environment, do a code scan, and come back out and say, okay, here's your build artifacts, here's your deployment artifacts, and here's a list of areas where you might need to make some changes to be able to come onto the platform. That code scanning, we kind of like to joke around and call it application archaeology, where we need to go in and look for, in all those nooks and crannies of, potential tripping areas and pitfalls. And that's a critical piece to help make it easier for the application teams to understand what they need to do to make that migration happen. Ultimately, though, is that we're going to have some platforms that are just not able to make the move, or, the reality is some teams are just unwilling to make that move. And so we'll need to be able to have a fallback option that can simulate those legacy platforms. Example of one is KubeVirt, being able to deploy, run, and manage virtual machines as if they were containers. And that's another, a fallback area where we can still make the migration, still get them onto the platform, and buy them a little bit more time to make the migration, or to let it continue running in that environment, and then make it easier for the operation teams to support it, since there's a single primary platform to be able to support. And then the last thing is that all of these tools, or at least several of them, need to plug into the existing pipelines. Anything that we can do to be able to make it easier for the application teams to take advantage of these tools is a key feature. And really what this boils down to is that speed and accuracy are paramount. Being able to give accurate information about what it's going to take to do the migration to the app teams will help allow them to make the decision willingly to trigger that migration. And that's where these migration factories can then come in and help drive this even faster. Next slide, please. And so with that, my client's last sector is finally ready to make the migration to the OpenShift platform. And they're coming from PCF. So we have about 1,200 applications that need to be migrated. We have various levels of skills and engagement from the app teams. But most of them have little to no skills with Kubernetes and OpenShift. And so really, we already have some teams that were already looking to make the migration prior to the announcement of the efforts to do the migration. And so we want to take advantage of those teams and their experiences to help further refine the tool set. And so in this process, we want to leverage these Conveyor tools to help ease that migration. We actually did a demo of Move to Cube and plugged it into a PCF environment. In fact, it was actually a Bluemix environment. And used that to kind of spit out those Kubernetes artifacts. In fact, we actually found a bug in the output where it actually doubled up I believe it was the route, and actually caused a failure of the deployment. And my resource who discovered that actually submitted a PR back to the Move to Cube project to fix the issue. And then we're also looking at Migration Toolkit for Applications, or what's being renamed and merged with Pathfinder, and it's now called Tackle. We want to use that to help identify those common pitfalls and help try to automate that application archaeology. And finally, my team is actually very much interested in working with the community to take this body of work that we're about to do and feed it back into the Conveyor tools community, so that we can help other teams and other clients be able to do the migrations and make it easier for them to actually happen. So this is a fantastic opportunity for the community and for my team to be able to come back and give back to the community based on our experiences at a very large environment. And next slide, please. And with that, I'm going to turn it back over to Justin, who's going to talk a little bit more about the Conveyor tool. Thank you.
Hey guys, and thank you, Ryan, for that. That was awesome. So let's talk a little bit about the Conveyor tooling, what we used and kind of what we can use in the future, right? So Ryan mentioned Application Migration Toolkit, or Migration Toolkit for Application now. That's wind up in community land. So this basically analyzes Java applications and has a set of rules for example, cloud readiness, how to move from standard Spring Boot to Red Hat supported Spring Boot, move from WebSphere or WebLogic to JBoss, and this is super powerful. For moving into OpenShift, especially if you're running on things like WebSphere or WebLogic and you want to move to JBoss first. And that's really important, and we've done that before, where basically the first move we make is to JBoss, so that then it becomes really easy to run on OpenShift, because we support JBoss on OpenShift, and we have a way to cluster JBoss on OpenShift and everything out of the box that Red Hat provides, supporting all of our middleware on it. Pathfinder is the tool for assessing the applications suitability for container. It's basically, questionnaire driven to basically try to learn more about our applications. Ryan talked a little bit about move to kube already. So this could have been actually really useful for us when we did our Bluemix migration. I just don't think it was really, much around yet because Bluemix was Cloud Foundry based. So moving from, a Cloud Foundry solution to OpenShift, this really could have helped. Forklifts for moving virtual machines to Kubernetes. This is starting to be something that we're seeing a lot, right? KubeVirt is now supported in OpenShift, so we can run virtual machines inside of containers as part of OpenShift. So let's kind of think about what happens when when we're moving an old school legacy application. Maybe there's some Windows Windows host, things that it's a bit harder to move everything to OpenShift at the same time. Forklift and really KubeVirt in general, it can be powerful here because you can move some things into containers in OpenShift while moving some things into VMs in OpenShift so that everything can be in OpenShift at the same time. You can take use of all of our CI/CD and deployment paradigms for how do we deploy to OpenShift while still running a VM, right? And then slowly you can migrate your VM hopefully into containers as long as it's as long as something is feasible there. That's starting to see a pattern that we're using more. And then Crane, which is a tool for moving applications between Kubernetes clusters. So if you're running on standard kube and you want to move to OpenShift, or even if you're upgrading from OpenShift 3.11 to 4.6, Crane can be helpful there, right? So Windup or a migration toolkit for application and Pathfinder are kind of being merged under Project Tackle now. Just a new community name that kind of is encompassing of both of those tools and will eventually grow beyond that. And plus, I don't want to forget about Polaris, which is basically basically a set of dashboards that measures how well we're doing in deploying into OpenShift. So it measures things like how often we deploy and stuff like that to try to create dashboards and executive summaries to kind of show the value of why and what we're doing. Let's talk a little bit about skills. And I'm sorry for, I kind of laid this out in terms of Red Hat training, which is great and useful, but we can talk a little bit about just like the skills required and what different people need to know. Ryan mentioned about the skill set of the developers at his client. I didn't really talk about that, but they were obviously wildly varying. Some people were really good and really excited to learn new technologies, and some people weren't. They just kind of wanted to do what they did before, right? So that's part of the reason why we built so much of that standardization, so that we can deal with developers of different skill sets, so that people didn't really want to learn that much about Kube. They didn't have to, but it is really important. So I broke this up under two categories, right? Application developers, so the people that are coding, writing the application, then application operators. So these are maybe some of your like DevOps people. So not really people that are managing the cluster, but people that are managing the applications and the deployments and things like that. Right. So these first two courses are kind of a lot about just how do we containerize applications in a whole, and just kind of high overview on containers and Kubernetes. But I think this is important for both of those roles to know. Like the operators might not be developers entirely, but they should still know the basics of how do we containerize an application, Docker files, and all that kind of stuff. And all the Kubernetes and OpenShift objects, obviously, that's really important for operators, but also developers if they're kind of going to be influential in the design decisions of how they deploy their app on Kube. Then we can get some of the courses that are more around like newer Red Hat technologies, microservices development, Istio, things like that. Maybe more important for developers. Quarkus is another really cool tool. Quarkus is basically, what do they call it? Subatomic super speed Java. So it basically allows you to compile Java natively so that you can spin up a native image with Java. So it can spin up way faster than like, Spring Boot. We use way less memory. It's super powerful. Like things like that, your operators don't necessarily need to know about because that's more development paradigms. Istio, if you're implementing microservices architectures, kind of both need to know because Istio, you don't really change your application code to work with Istio. Istio has a proxy that sits in front of your app, so you can inject all your configuration into that for how to deal with ingress and egress traffic, connection between various services, rate limiting, throttling, circuit breaking, all that kind of stuff. It kind of breaks it out from the application itself and puts it in a sidecar and injected via config. So that's kind of important for both teams to know. Most of these trainings are paid Red Hat trainings, but again, the topics is more what I was talking about. A lot of these topics also have free kind of smaller versions at developers.redhat.com/training, right, where you can do some free training, work on some free labs, and definitely a lot of great content there to learn about all these technologies. Also, some great information on migration toolkit for application or wind up on developers.redhat.com, and some really easy tutorials to start looking at how you can use wind up to move applications to OpenShift, or really just move applications to JBoss or really any supported Red Hat platform. Here's a link to a survey if you want to let us know how we did and give us any information. But that's all we got for the presentation. So now the floor is open for questions. Let's see what we got so far, but feel free to type any questions in the Q&A. So the first one I see is, do your customers have network segment requirements to isolate their networks in their data center? If so, what was the solution that you used? Sort of. Usually, there's more isolation requirements between on-prem data centers and cloud data centers. Between multiple data centers within their own environment, I haven't really seen too many isolation requirements. But usually, at least like port 443 is open, so you can communicate via routes when you're going between OpenShift clusters in different data centers. If you need, to communicate on other ports, you might need to open other firewall rules, but don't really know if I have a great answer for you. I would need to kind of understand your guys' topology of your network to really give you any good answers there.
Yeah, I can jump in on some of this because I already typed in a reply as well. But for my particular case, my client is looking to leverage microsegmentation, and they're currently looking at a variety of different solutions. And for containers itself, they're actually looking at service mesh as one of the tools to help them do their microsegmentation. But that's it's still an ongoing effort. They haven't made a tool selection yet, but we are working with them to identify and test various solutions.
So that's the only questions I see right now. Thank you guys for joining. We'll stick around for until noon. If you guys have any more questions, we'll be happy to answer. But thank you.
Thank you guys everyone for checking in. And there's another question, Justin, that was like right before that. Ryan provided an answer for it, but curious to get your take on it. So William asked, we automated some of this onboarding process, and can this onboarding be templated? And this is referring to like the beginning of your presentation.
Sure. Sorry that I missed that, William. Yes, a lot of it can be templated. A lot of the solutions that we built, and let me go back a couple slides to kind of talk through this. Right, like the step number one, like the onboarding over here, they kind of built like their own portal to do this. So this would be kind of hard to kind of repeat anywhere. It's pretty simple. It's just like integrating with their AD to give the right permissions to the right people. But this was like a portal, like an actual UI that they built. So this would be kind of hard to standardize. Configurations and secrets, a bit easier, right? We can that can definitely be templatized and used across multiple clients. They might each want to modify it in their own way. But again, like that's more doable. Logging too, and a lot of these vendors provide solutions to do it. Like Splunk has their own sidecar. So a lot of these vendors provide kind of more templatized solutions. All this stuff, yes, a lot of this can be pretty templatized, right? Like Red Hat already provides the base images, or a lot of them, and some vendors do too. We're just layering some layers on top of it. But things like the object store integration, MTLS, yeah, we can probably build a lot of these outside the scope of our clients so that we can use them across many places.
Awesome. And there's another question which Ryan answered as well, but it'd be worth pointing to you as well and get your input. So what is the approach to encrypt traffic between apps, pods, nodes in the OpenShift cluster?
That's a very good question, and ends up being a bit of a struggle, right? So if you're using Istio, this is easier, right? Like Istio can, within the service mesh, have everything communicate over TLS out of the box. You don't need to do it. If you want to enforce it beyond that, it's a little bit more tricky. In 3.11, you could have your SDN with IPsec enabled. IPsec basically encrypted all the traffic between the pods. That hasn't been around for a while. It is coming back with OVN though, I think in 4.7. It might be 4.8, I'm not sure exactly when, but if you want to encrypt all traffic within Kubernetes and you're using OpenShift, right now the right approach, if you're not using Istio for service mesh, is to probably use IPsec as part of OVN. Unless you want to, if you want to enforce it, or you can kind of just state that as like a standard, like all traffic has to be encrypted, but there's no really good way to enforce it besides using Istio or IPsec.
Okay, and then we have another one, and this one's specific for you, Justin. What tools did you actually use to deliver at custom use case number 1? You presented on the Conveyor tools, but they want to know which ones you use primarily for the specific use case.
So we did use WindUp or a migration toolkit for applications for some of the workloads. But again, that project, it took a while. It was about a year-long effort to move, maybe a little less, and a lot of it was before some of these tools existed. So most of it we honestly built ourselves, right? If we did this again today, definitely use a lot more of these tools from Conveyor. Obviously use Move to Kube to facilitate the Cloud Foundry migration. But we built a lot of it ourselves, which has both merits of we got to build exactly what we needed, but it probably took us a little more time than it would have taken us today because we had to do a lot of it ourselves. Some of the standardization, like how do we build a standard CI/CD pipeline? How do we build a way to do onboarding, all that stuff? That's not really a tool that can do that today, so that you kind of have to do yourself. But in terms of the migration tooling, yeah, I definitely would have changed how we did things and used more of the tools within Conveyor.
Okay. I think, and it looks like that was the last one. So Justin, Ryan, thank you. What we can do, guys, in case anybody has any more questions, is when I send out the recording, I'll just put a link to our Slack, and Justin and Ryan can answer any questions there. All right, guys. Well, hope you enjoy the rest of your day.
All right. Thank you very much.
Thank you.